So we're going to start here with polynomial division. So there are two types of polynomial division. One is synthetic division and one is long division. I'm going to show you both on this example, and then we're going to go through when can you do synthetic division versus when can you do long division. So when we do long division, we do long division the same way that we do long division like with numbers. So this would be t minus 3 on the outside. I drew a square root instead of a division. Oh well.
You know you're not projecting, right?
Oh, I forgot to share screen. Duh.
Okay.
Thank you. Okay, so better. Okay, so then, and then on the inside, we put the t to the fourth plus 3t to the third minus 3t squared minus t plus 1. And then we ask ourselves, don't worry about the minus 3. We just ask ourselves, how many times does t go into t to the fourth? That's similar as saying, what do I multiply this by to make it this? So what would I multiply a t by to make it t to the fourth? That would be a t to the third. And then you do that multiplication. T to the third times t is t to the fourth. And then you also multiply t to the third times a negative 3 is a negative 3t to the third. Now, just like with long division with numbers, my next step is going to be to subtract. T to the fourth minus t to the fourth cancels. 3t to the third minus a negative 3t to the third is 6t to the third. And then we bring down our next term. Okay, what do I multiply this by, this t? What do I multiply it by to make it look like this? Well, it needs the 6, and then there's only one t, and we need 3 t's. So I would multiply it by a 6t squared. And then you do that multiplication. 6t squared times t is 6t to the third. 6t squared times a negative 3 is going to be negative 18t squared. Then we subtract. 16 to the third minus 16 to the third cancels. Negative 3t squared minus negative 18t. Remember, minus a negative becomes positive, so this is going to be 15t squared. And then we bring down the minus t. Okay, what do we multiply this t by to make it a 15t squared? That's going to be a 15t. So 15t times t is 15t squared. 15t times a minus 3 is negative 45t. Again, we subtract. Those are going to cancel again. Negative t minus 45t is going to be a 44t, right? Because a negative 1 plus 45 is going to be 44. And then we bring down the 1. What do I multiply a t by to make it a 44t? 44. And as soon as you have no more t's up here, this means that this is going to be my last step. (44 times t is 44t. 44 times a negative 3. (132). Subtract. And then 1, so these are going to cancel. 1 minus a negative 132 is a positive 133. So then your remainder is this 133. So what I am doing right now is I want to see how Moore wants the answer formatted. Okay, so then in order to show that this is a remainder, you're going to say that this is plus whatever your remainder is over whatever you were dividing by. So plus 133 over t minus 3. Okay, that's how Moore wants that formatted. So polynomial long division is the same as regular long division with numbers. It's the same set of steps. It's just a lot more algebra. Now for this one, whenever you have just a variable and then plus or minus and then a number, you have the option of doing synthetic division. So for synthetic division, you're going to turn your divided by bar upside down. You're going to take just your coefficients from your numerator. So that's a 1, a 3, a minus 3, a minus 1, and a 1. And then you're going to take this number and you change its sign. So if this is a minus 3, you put a plus 3 out here. And now we're not going to do any division. Synthetic division is all multiplication and addition. So the first thing we do is we bring down our first term. Then we take whatever is down here and we multiply it. So what is 1 times 3? That is 3. And that's what goes up here. And then we add the column. 3 plus 3 is 6. Then we multiply what is down here with what is out here. 6 times 3 is 18. Then we add the column. Negative 3 plus 18 is 15. Are you seeing how? See it? 1, 6, 15. Okay. 3 times 15 is 45. Negative 1 plus 45 is 44. 3 times 44 is 132. 1 plus 132 is 133. So this last number is always your remainder. So that always goes over whatever you were dividing by up here. Then you have a constant, a term with just a t, and then you go up in degrees from there. See how I got the same thing? Now again, synthetic division, while awesome, only works if your denominator looks like this. So you see how here I have an r squared? I can't do synthetic division. You see how here I have 3 terms? Nope. I can't do synthetic division. But you see how right here all I have is a plus 5? I can do synthetic division on this one. Okay? All right. So for this next one, we're going to have to do long division because of the squared. So let's set this up. 6r squared plus 7, 6r cubed minus 48r squared plus 13r minus 53. Okay, so what do I multiply a 6r squared by to make it a 6r to the third? That's going to be just an r. R times 6r squared is 6r to the third. R times 7 is 7r. I'm going to put that over here under the like term. I'm not going to put that here because 48r squared would not combine with the 7r, right? But the 13r will combine with the 7r. 6r to the third and 6r to the third cancel. Negative 48r squared minus nothing is just a negative 48r squared. (13r minus 7r is 6r. And then let's bring down that 53. Okay, now what do I multiply a 6r squared by to get to a negative 48r squared? That would be just a negative 8. And again, since all I have up here right now is a constant, that means this is going to be my last step. So negative 8 times 6r squared is a negative 48r squared. Negative 8 times 7 is a negative 56. And again, I'm going to move that over so that it's with the other constant term. Then I'm going to subtract. These are going to cancel. There's nothing to subtract from 6r, so it comes down. And a negative 53 minus a negative 56 is negative 53 plus 56, which is 3. And so then up here, you would put plus, and then 6r plus 3 over 6r squared plus 7. A very gentle reminder that in more, you're going to make sure that you leave the parentheses here and here. Otherwise, it's not going to work. And then it doesn't ever hurt to hit that preview button and make sure that it looks on your paper the same way as it does, the same way as they want it. Because if you left those parentheses out, it would look like this when you hit preview. Because it would only do the division of these two things if you didn't have parentheses there. Okay? So don't be afraid to use that preview button and more to make sure that it looks on your paper like you want it to, like it looks in the computer the same way that it looks on your paper. Okay. All right, let's do another long division example. Okay, so we're going to start the same way. Again, I'm only worried about my first terms. So what do I have to multiply a 2w squared by to make it negative 14w to the fourth? I need a negative 7w squared. And then I multiply this whole thing by that. So negative 7w squared times 2w squared is a negative 14w to the fourth. Negative 7w squared times a negative w is going to be plus 7w to the third. Negative 7w squared times a negative 3 is going to be plus 21w squared. This subtraction is going to be the step where you're going to make the most mistakes because you're going to forget to carry that subtraction through the whole thing. So please remember that we are subtracting everything. Because a negative 7w cubed minus 7w cubed is a negative 14w cubed. Got it? 38w squared minus 21w squared is 17w squared. And then let's bring down the 16w. Okay, so a 2w squared to get to a negative 14w cubed will be a negative 7w. Negative 7w times 2w is negative 14w cubed. Negative 7w times negative w is a plus 7w squared. negative 7w times negative 3 is a plus 21w. And again, we subtract. This first term will cancel, as it always should. 17w squared minus 7w squared is 10w squared. 16w minus 21w is 5w, negative 5w. And then bring down the 23. Okay, 2w squared to get to 10w squared, that's going to need a 5. And again, now that I just have a constant right here, I know that this is my last run through. So 5 times 2w squared is 10w squared. 5 times a negative w is a negative 5w. 5 times a negative 3 is a negative 15. That was a minus 23. I forgot to bring the sign down. And then we subtract. These will cancel. Negative 5w minus a negative 5w will cancel as well. And negative 23 minus a negative 15 is negative 23 plus 15, which is a negative 8. So then plus negative 8 over 2w squared minus w minus 3. Okay. Now for this last one, you can do synthetic division, and you should. Any question where you can do synthetic division, please do. Make your life easier. So again, we know here that we can do synthetic division because it's just a variable plus or minus a number. And so I'm going to set up my synthetic division. The divided by bar falls over. I'm going to line up my coefficients. Ready? What did I just do?
You added in your spot for the
Zero.
missing X.
Yeah.
There is no term with just an A. That means there is 0A. So you have to include that 0. If you do not include that 0, you will not get the right answer. So it skipped a term. You are not allowed to skip a term. Okay? But then this 5, again, we change the sign and we bring it out. 1, negative 5, add negative 1, multiply positive 5, add 5, multiply, that's going to be negative 25, add negative 3. And then again, from here, I always go backwards. So this is my remainder. I'm going to bring this minus sign to the outside. This is my constant. This would have just an A, and this would have an A squared. So we're going to be using a lot of synthetic division in 3.6. So I hope that you're okay with it. That it's not like, oh no, synthetic division.
I don't know why I'm having like so much trouble with the polynomial long division when you did squared.
Long division sucks.
I just I keep getting that one wrong. Like I don't know.
Okay, so when we're talking about polynomials, the rational root theorem tells us that if a rational 0 exists, it is a factor of the constant divided by a factor of the leading coefficient. So Here, my constant term is 35, and my leading coefficient is 33. So I need all of the factors of those numbers. The factors of 35 are 1, 5, 7, and 35. The factors of 33 are 1, 3, 11, and 33. So then my possible zeros are all of these numbers over all of these numbers. So that's 1 over 1, which is just 1, 1 over 3, 1 over 11, 1 over 33, 5 over 1, which is just 5, 5 over 3, 5 over 11, and 5 over 33. Then 7 over 1, which is just 7, 7 over 3, 7 over 11, 7 over 33. Then 35 over 1, which is just 35, 35 over 3, 35 over 11, and 35 over 33. So those are all of my possible zeros. Which is not, so then which one of these is not? Five over 7. Five over 7 is not in my list, right? Okay. Now, if we want to write this as the product of linear factors, the first thing that I always do is I graph these, like always first. And sometimes the graph helps and sometimes it doesn't. But it's worth trying. 20x to the 5th, 138x to the 4th, 362 x to the 3rd, 44 x squared, 248x, oops, plus.
I think you might have been missing a 4 in your equation for the 444.
Oh no, let's check. Oh, you're right. Thank you. Okay, now I want to go to the table and see if there are any, it's still graphing. Okay, see how right here I have a 0 at -2? Then that means for sure W equals -2. Also for sure W equals -1. That's helpful. Looks like that's it. Hey, I'll take it. Now, this, nah. So we know for sure -2 and -1. So what I'm going to do is I'm going to use synthetic division, and I'm going to take those out. That's where I'm going to start. Get rid of them. So 20, 138, 362, 444, 248, 48. Now, keep in mind that w equals -2 would be a factor of w plus 2. This will be a factor of w plus 1. So when we put our numbers out here for synthetic division, you use this number. Remember on the last one, I said you flip this sign? So we flip this sign and we get this number. So we're going to divide out a -2. It's going to be -40. 138 minus 40 would be 90. 98 times 2, -196. 362 minus 196. 166 times a -2. -332 plus 444. 112 times a -2. -224 plus 248. 24, -48, 0. That 0, no remainder, means that this goes in perfectly. We don't need that last column. We're going to do synthetic division again, only on this. We're going to take out this -1. 20, -20. So that's going to be 78 times a -1 is a -78. 166 minus 78 is 88. Times a -1 is a -88. 112 minus 88 is 24. Times a -1 is -24. All done. Okay, now is when you need the rational root theorem. So here we have a cubic term, right? If we started from the back, you would have no remainder. This would be a constant, and then a t, and then a t squared, and then a t to the third. I need to keep going until I get something squared, because a squared term, I can use the quadratic formula or factor or something else. So here, I'm going to have to use the rational root theorem to try to find another root, because if you look, this definitely crosses between 0 and -1. So I'm looking for that root right there. So the factors of 48, excuse me, are 1, 2, 3, 4, 5 doesn't go in, 6 goes in, 8, and then we're back. So 12, 3 goes in 16 times, 2 goes in 24 times, and then 48. And then the factors of 20 are 1, 2, 4, 5, 20. Okay? So I would have all of these numbers over all of these numbers. That would be a lot of work. Let's keep in mind that I need something between 0 and 1. So that would be 1 over any of these. So it could be 1/2. It could be 1/4. It could be 1/5. It could be 1/20. Now looking at this, it doesn't look like it's 1/20. It's like too close for that. You know what? Let's see if the calculator can help me even more. Go to second and then calc, second and then trace to get to calc, and then choose option 2 for 0. And let's see if the calculator can tell me what that 0 is. Where's my cursor? Here it comes. Okay, so the left bound would be anywhere to the left of that 0. The right bound would be anywhere to the right of that 0. Right there is good. And then ignore guess. 0.4. Is one of these 0.4? No. 2 over 5 is 0.4. So 2 over 5 is one of my rational roots. And now, thanks to the calculator, I know that negative 2 over 5 is a 0. So let's take that one out. Your other option is to go through this whole list and test them all, which is really dumb. Bring down the 20. 20 times 2/5. Well, 20 times 2 is 40 divided by 5, so that's 8. Then that would be 70. 70 times 2/5 would be a negative 28. That's a negative 2/5. And then 60. 60 times a negative 2/5 is a negative 24. There we go. 0. Okay, so here's what I have left. I have 20x squared plus 70x plus 60. If at this step you have a GCF, get rid of it. We're going to take that 10, and we're not going to worry about it right now. Now, does this factor? 2 times 6 is 12. Are there two numbers that multiply to 12 and add to 7? So then that's an x, 2x plus 3. That's a 2, 2x plus 3. So what I have here is x plus 2 times 2x plus 3. Now, remember this one that I got right here? You need that one also. I need like a better space to write this in. Oh, I'll do it up here. So x plus 2, 2x plus 3. This one, this one, and then this. So here, if we have w equals negative 2/5, to get this to be a factor, I would multiply both top and bottom by the 5. So 5w equals negative 2. And then I would move the 2 over. So then that one is 5w plus 2. Huh. This one was a lot. And then the only other thing that I want to point out to you is that if you check your leading, which you probably should, or your constants, 2 times 3 times 2 times 1 times 2 is only 24. And what did I need it to be? 48? So then that means that I should have had a 2 in front here that I lost. So it's always good to check your constants at the end and make sure that your constants all multiply to this. And if they don't, add a leading coefficient to make that happen. Okay, let's try it again. Here they gave me a 0. If they give you if they give you an imaginary 0, then its complex conjugate is also a 0. So really, when they gave me 1, they gave me 2. Now, I am going to take the step to graph this to see if I can get any other zeros from the graph. So x to the 6th, 7x to the 5th, plus 40x to the 4th, and maybe 6x to the 3rd. Oops. There we go. Minus 186x to the 3rd, 377x squared, 275x, 50. Okay. That all look right this time? So just like I did on the question above, I'm going to take the time to graph this and see if I can get any other zeros from the graph, because it certainly made my life easier when I found them. Wow, that was helpful. Check the table. Look at that, both 1 and 2. Any others? No. Nope, no other zeros. All right, hey, you know what? That's 4 out of 6. So I'll take it. All right, let's start with our real first, because I don't want to do 5 and 5i with synthetic division until I absolutely have to. So 1, -7, 40, -186, 377, 275, and 50. Let's do 1 first. So 1, -6, -6, 34, 186 minus 34, 152, 152. One of those should have been a minus. What did I do? Oh, that should be a -152. So the -152, which is 275. Nope, it's 225. Right? 377 minus 152 is 225. 225, -50, -50, 0. Okay. Now that I did the easy one, let's do the 2 next. 1, 2. It's going to be a -4. So -8. 26. 26 times 2 is 52. So that's going to be -100. So that's going to be -200. It's going to be 25, 50, 0. All right. Synthetic division with imaginaries functions the exact same way. So we're going to put a 5i out here. We're going to bring this down. 1 times 5i is 5i. This would be -4 plus 5i. You can't combine those. They're not like terms. But now I have to multiply -4 plus 5i times 5i. I'm not doing any of that by hand. I want you to know that. I don't expect you to. I'm not going to. 5i times, nope, not 51. 5i times -4 plus 5i. -25 minus 20i. So then I'm going to add 26 to that. 1 minus 20i. Then I'm going to multiply that times 5i. 100 plus 5i. Then I'm going to add that with negative 100 and just get 5i. Then I'm going to multiply that times 5i. Negative 25. So again, I'm not doing any of that by hand. I'm not expecting you to do any of that by hand. And if we have 5i, then we also have negative 5i. So let's do negative 5i next. 1, negative 5i. A negative 4 plus 5i minus 5i is just a negative 4. So then a negative 4 times a negative 5i is a plus 20i. And then look at what happened again. 1 minus 20i plus 20i is just 1. And then 1 times a negative 5i is a negative 5i. Those cancel. I have no remainder. This is my constant. This is my term with just a t, and then this is a t squared. So then the last thing that I have to do is I have to do something with this because they want a product of linear factors. So far I have 4 linear factors. I have x minus 1. I have x, oh, these should be t's, excuse me. I have t minus 1. I have t minus 2. I have t minus 5i and t plus 5i. So t squared plus 4t plus 1. I'm going to use
Is it t squared plus 4t plus 1? How's the
minus 4t.
beginning of it?
You're right.
Oh, okay.
Sorry about that. I'm going to go through and check exactly how they want this to look. There we go. So this one doesn't factor. So we need to use the quadratic formula. Completing the square would work nicely on that one, but I don't know how many of us remember completing the square. So t equals a negative b, so a negative negative 4, plus or minus the square root of b squared minus 4 times a times c over 2 times a. So that's going to be 4 plus or minus the square root of 16 minus 4, so that's 12. 12 reduces because the square root of 12 is the same as the square root of 4 times the square root of 3. So that's 2 rad 3. I just realized you can't see what I just did. And then you cover up your square root. Is there anything you can divide out of all 3 of these? Yes, a 2. So then that would be t equals 2 plus or minus rad 3. So your 2 roots there are 2 plus rad 3 and 2 minus rad 3. And so if we're thinking about this in terms of how to make it look like that, Remember, the idea is to turn this into something that equals 0. So hang on, let's do them one at a time. So here I would subtract the 2. And then I would subtract the square root of 3. So t minus 2 minus the square root of 3. And that is my factor. And then my last factor would be when t equals 2 minus the square root of 3. So when we move these back over, both of their signs switch. So it would be t minus 2 and plus the square root of 3. And that is my other factor. These are a lot. I'm not even going to attempt to pretend that they're not a lot because they're a lot. All right. Okay. So, degree 5 passes through the origin means that, use t, okay, means that t equals 0 is one of your zeros. Has zeros at I. If it has a 0 at I, then it has a 0 at negative I. 8 minus I, then it also has 8 plus I. Of degree 5, that's 1, 2, 3, 4, 5. That's all of them. Now this point, that 5, 2600, is going to be used later to help me figure out if I have a leading coefficient. But for right now, I have factors at t minus 0, t minus I, t plus I. And then again, remember when we move these over, both of their signs switch. So t minus 8 plus I and t minus 8 minus I. T minus 0 is just t. And then I'm going to do this multiplication out over here. So do the complex conjugates separately. So what I mean by that is I'm going to do t minus I and t plus I. And then I'm going to do t minus 8 plus I and t plus 8 or minus 8 minus I. And over here, I'm just going to FOIL. So t times t is t squared minus ti, and then plus ti minus I squared. But in the middle, a minus ti and a plus ti cancel. And remember we said I squared is negative 1. So I have t squared minus negative 1. So this is t squared plus 1. So over here, I have just a t. These two, when I multiplied them together, gave me t squared plus 1. Now let's see what I get when I multiply these two together. Anyway, let's just do it. T times t is t squared. T times 8 times a negative 8 is a negative 8t. T times a negative I is a negative ti. Okay. Negative 8 times t is a negative 8t. Negative 8 times negative 8 is a plus 64. I'm trying to line up my like terms. negative 8 times I is a negative 8I. I times t is a plus ti. I guess I should do that in a new row. Plus ti. And then I times a negative 8 is a plus 8I. And I times a negative I is a negative I squared. But we just said over here that a negative I squared is a positive 1. Now, all I did right here was I did like the lines, that way I could keep my like terms together. So there was nothing like with a t squared. I have a negative 8t and a negative 8t, so that's negative 16t. And then a negative ti and a positive ti cancel. 64 plus 1 is 65. And a negative 8i and a positive 8i cancel. See how all my i's went away? You will know that you did this right if all of your i's canceled like that. I feel like, yep, cool. So then these, when I multiplied them together, became t squared minus 16t plus 65. Now, and this is a place where more is nicer than I am, because if it were me, I would make you multiply this through and then multiply all this, but it's not going to make you do that. So you can just put exactly like you see it here, t squared plus 1, t squared minus 16t plus 65. Now, the only other thing we need to do is we need to figure out, is there a leading coefficient? And I'm going to use this to do that. So what I'm going to do is I'm going to plug a 5 in. And let's see what we get. So if I do 5 times 5 squared plus 1 times 5 squared minus 16 times 5 plus 65. What did I get? 1,300. So when I plug in 5, I got 1,300. I wanted to plug in 5 and get 2,600. So when I plugged in 5, I got 1,300. I was expecting 2,600. So I need to know what number would my leading coefficient be in order to multiply this 1,300 to get 2,600. And in this case, that would just be a 2.
So did you just divided, right?
Yeah, 2,600 divided by 1,300. Yep, 2. Okay, so then last but not least, here, questions, that's annoying. Okay, so here, the degree in standard form, the degree is always your biggest exponent. So here that's a 6. My leading coefficient is the number in front, so that's a -1. And then from last week, we should remember that even degree and a negative leading coefficient means end behavior down and down. Now, while I'm here, I have to tell you that one of my biggest disappointments in the world when I was looking at your tests is that I don't know how many of you mixed up right hand end behavior and left hand end behavior. That your end behavior was correct. You just flip flopped these two because you went from left to right instead of seeing right hand is this side and left hand is this side.
It might just be math dyslexia, because I noticed I did that with some of my numbers too, where it was supposed to be like 67, but I put 76.
I was
It just,
like,
and it looked right to me.
guys, guys. So right hand is that side. So that means that as r approaches positive infinity, k of r is going down. So that's negative infinity. That was a really ugly infinity sign. And on the left side, as r approaches negative infinity, k of r is going down negative infinity. Okay. They gave us 1 0, but really they gave us 2 zeros. Because if we have 4i, then we also have negative 4i. Now we're expecting 6 zeros. So, I mean, we could try to graph this one. I don't know that we'll see any on the graph, but let's give it a shot. Negative x to the 6th minus 13x to the 5th, 75x to the 4th, 321x to the 3rd, 1022x to the 2nd, 18x, 1230. Oops. Ooh, I'm missing a couple things. Insert a plus sign. Insert a 0. 1808. 1022. 321. 75. Oop, that should be a minus 13. Glad I checked. 2 minus 75 minus 321 minus 1022 minus 1808. Jeez, I sucked at this one. Good thing I checked it. Minus 1248. Okay. Oh, that one was close. Ooh. Oh man, that would be awesome. Let's check the table. Check the table. There we go. Aha! -3 and -2. That's super helpful. Okay, so I'm going to do my synthetic division. -1, -13. I'm going to give myself a little space because of those eyes. -1, -13, -75. I might have just run out of room. Okay. -1, -13, -75, 1022. Ugh. Okay. Those are gross. Let's do the -3 first. That's going to be a +3. So that's a -10. That's a +30. It's a negative 45. So negative 45. Figure out a good place to put this. Negative 45 times negative 3. 135 plus a negative 321, negative 186 times a negative 3, 558 plus a negative 1022, negative 464 times a negative 3, 1392 plus a negative 1808, negative 416 times negative 3. There we go, 1240. Okay, now let's do the negative 2. Negative 1, that's going to be a positive 2, so negative 8 and a positive 16. If it were 15, that would be 30, so it's 29. All right. So then negative 29 times a negative 2 is 58 plus a negative 186, negative 128 times a negative 2, 256 plus a negative 464, negative 208 times negative 2 is a positive 416. So far, so good. All right, now we have to do the i's. So let's do 4i. Negative 1. Negative 1 times 4i would be a negative 4i. You can't combine these, so that's a negative 8 minus 4i. Okay. So then 4i times negative 8 minus 4i. There we go. Negative 32 plus 16i. And then plus a negative 29, negative 61 minus 16i times 4i, 64 minus 244i, minus 128, negative 64, oops, minus 244i, times 4i, times 4i. Oh. What did I do? That should have been just a regular. Okay, let's go back and see where I screwed up. Negative 32.
The 244, negative 244i and the other 244i should cancel out right there, right? So then you're only multiplying the 4i. No.
No. Okay,
Right.
let's go back and try it again. Negative 8. This was 4i times negative 8 minus 4i. Because the 4i is the one they gave us, right? Yep, 4i. 16. Oh, look, I transposed them. I put negative 32 plus 16i. If I take that and I add a negative 29, My fault. So this should have been 16 minus 32i. And then negative 13 minus 32i. And then times 4i. 128 minus 52i. Yep. Because then when I add a negative 128, I get just a negative 52i times 4i, 208. One more. Negative 4i. Bring down the negative 1. It's going to be a positive 4i. These are going to cancel. Negative 8 times a negative 4i would be a positive 32i. These are going to cancel. And then negative 13 times a negative 4i would be a positive 52i. And then that's gone. So we are left with a negative 1r squared minus 8r minus 13. I'm going to GCF out a negative 1. I guess we could just do the quadratic formula that way. It's not my favorite way, but whatever. R equals a negative negative b, so that's a positive 8 plus or minus the square root of negative 8 squared times 4 times negative 1 times negative 13 over 2 times negative 1. Let's see. Negative 8 squared minus 4 times negative 1 times negative 13. Square root of 12. We already did the square root of 12. Square root of 12 was 4 rad 3. Right? 2 rad 3. 2 rad 3. Okay. Is there anything I could divide out of all three of these? Yes. So when you divide an 8 divided by a negative 2, you get a negative 4. When you divide this plus or minus by a negative 2, the plus would become the minus and the minus would become the plus. So really on this side, you just have the rad 3. That plus or minus kind of is unaffected by the minus because it's both of them. So then my complete list of, so then I have negative 4 plus rad 3 and negative 4 minus rad 3. And so then in factored form, it would be t minus 4i, t plus 4i, t plus 3, t plus 2, t plus 4 minus rad 3, and t plus 4 plus rad 3. Now, our intercepts sounds like it would be hard, but we actually already found them. Any real value in your zeros are also intercepts. So your intercepts would be at negative 3, 0. Oh my God, that was the other thing that so many of you did. You messed up your horizontal and your vertical intercepts. And I was like, horizontal, vertical. You guys, it was another thing that I was like, guys. And then -4 rad 3, -4, excuse me, plus rad 3. -4 minus rad 3. So the only difference between zeros and intercepts is that if you have an imaginary 0, that does not make an intercept. It's all of your real zeros that make intercepts. And then the easiest question on the page, the K of R intercept, well, that's the one where we make R 0. So if I made R 0, this would go away, go away, go away, go away, go away, go away, and we're left with just this last number. So the constant term is my K of R intercept. Okay. Oh, that was a lot. First one's not as bad as the second one, I don't think, but that's just me. Do me a favor, and before you forget,
I had a quick question.
yeah,
For the page that you just had up, when you found the R-intercept and it was like radical 3, 0, is that what I saw?
Yeah.
Why did we do that?
because it's a point.
Okay.
The intercepts are a point on the graph. So I take all of my real values up here. This is where it would cross the x-axis.
Oh, okay. Duh. Okay, thank you.
You're welcome.